Very good morning to all of you. Today we will discuss about the chapters acid, bases and salt, standard 10 as per the CBSE board. All of you know that thousands of years ago scientists they could not understand why the fruits like lemon, orange they are sour in taste. They could not understand. Only few hundreds years back they have understood it is sour in taste because it contains acids. The word acid comes from the Latin word acidus, which means sour. Similarly, base also meaning is that is the bitter taste. Now our chapter is acid, bases, salt, and subtopics is acid and bases. Let us see. Already I have told you the word acid comes from the Latin terms acidus, which means sour. In the same way, bases are recognized due to their bitter taste. Now, different scientists has given the different definition of acid and bases. As per the syllabus of CBSE board, we have the Arrhenius concept. Apart from this, we have the Lewis concept, we have the Bronsted and Lowry concept. Okay. Now, according to the Arrhenius concept, Arrhenius theory, that is the acid is a chemical compound which gives hydronium ion, H3O plus ion, as the only cation. Cation means positively charged ion in its aqueous solution. I repeat once again, acid is a chemical compound which gives hydronium ion as the only cation in its aqueous solutions. So, acid is a chemical compound, very important, which gives hydronium ion, H3O plus ion, as the only cation. Cation means positively charged ions in its aqueous solutions. Now, HCl, HNO3, H2SO4, acetic acid, lots of acids are there. Now, only cation, why the only cations? Here, HCl, we know it is ionizes to give the H plus and Cl minus. In aqua means water. The word aqua means water. In the water, H plus exists as H3O plus. That is the hydronium ion. Now, if we add this one, we will get HCl plus water. This will cancel out, reversible sign H3O plus. Here only cation is hydronium ion. So that is the definition is okay. Similarly, HNO3 also will give the hydronium ion, H2SO4 also will give the hydronium ion. But why the only cations? I am giving an example. If we dissolve sodium bisulfate in water, sodium bisulfate is NaHSO4 in water, what it will give? It will give the Na plus and H2O and H plus will combine to give the H3O plus. And SO4 double minus it will give. Here also H3O plus hydronium ion is giving. As per the definition, H3O plus is giving. But other cation are present in A plus. It is not the only cations. So that's why we cannot say this is acid. Sodium bisulfate is acid. The sodium bisulfate is not an acid. Is not an acid. Why it is not an acid? Because hydronium ion is giving, but apart from that we are getting the Na plus cation or positively charged ions. In the definition it is clearly mentioned as the only cations, So that's why sodium bisulfate is not a acid. Then what is that? We will learn later on. Sodium bisulfate is an acid salt, acidic salt. Now let us come to the some pictures from the source of defined part which contains acid. We know, we can see the sources of acid. I have already told you that lemon contains what acid? In the exam they used to give what acid present in the lemon? Okay, that is the citric acid. What acid present in the tomato? It is oxalic acid. Grapes, tartaric acid. Milk, that is the lactic acid. Curd also contains lactic acid. And formic acid. Why? When we and bites, we feel irritating because it secretes the formic acid. Okay, formic acid, and that's why we feel irritating. Now, apple contains malic acid. Vinegar, okay, vinegar is acetic acid. So these are the common source of some organic acids. Okay, we learned what is organic acid and inorganic acid, that we have later on we learn. Now I hope it is clear. So different sources of acids. So different fruits contains different acids. Okay, and why they are sour in taste? Because it contains acids. Now let us come to this pictures. We know acid, already told you, acid in solution means acid in water gives the hydrogen ion as the only cations. Acid gives the H plus, that H plus has very high affinity towards the water. That's why it does not exist as a H plus. It remains, it combines with the water to give the hydrogen ions. We know, we learn later on, it is a coordinate bond forms. Now, commonly H plus is giving, H plus in aqueous solution. Okay, we are considering. And similarly, bases we learn. Okay, common base example, soap contains bases. Okay, so the bases contain hydroxide ion. We learn later on. Today our topics is acid. So bases contain normally hydroxide ion. Now, so acid contains hydrogen ion or H plus ions. Acid sour in taste. It is sticky in touch. In solution, hydrogen ions rich in acid, and it turns blue litmus paper red. We learn later on, it is an indicator. Bases similarly, it gives hydroxide ion and it accepts protons. It is bitter in taste, it is slippery in taste. We know the soap is slippery because bases are slippery. In solution, hydroxide ion are rich and it turns red litmus paper to blue. And one more thing I am telling you, why solution bases hydroxide ion, why it is called bases, why a solution contain acid, why it is called acid. Acid and base both contain H plus and OH minus. In pure water, it is concentration of H plus ion and OH minus ion is same, that's why water is neutral. But when you add a small amount of acid to the water, then concentration of H plus increases, and that's why it becomes acidic. In the water, when you add a small amount of base, then concentration of OH minus increases, and that's why it is called base. Okay, and we learn later on acid and base react to produce salts and water. We learn later. So acid plus bases reacts to give salt plus water. One example we can write HCl, bases NaOH, and salt it will form NaCl and water. So lots of examples that there. When we will do the reactions, then we will discuss. Now let us come to the source of water. Some important acids and their sources. What are the different sources of water? In the exam they used to give what the tamarind contains, which acid contains. That's why we are giving some common source of acid. Red ant, that contains formic acid. Tea contains tannic acid. Gastric juice contains hydrochloric acid. In our stomach, bowels from the bowels it secretes the what? It contains what? That is the hydrochloric acid. And when you feel hungry, okay, so acid secretes from the stomach, okay, and it contains hydrochloric acid. If there is no food, then acidity increases. Now sometimes when acidity is more, we take the or the some other acids like say diazine, sorbacid, etc. What that contains? That is the base. Okay, that contains bases. Okay, so that is called antacid. That we will discuss later on. Now tomato, oxalic acid, curd, lactic acid, vinegar, acetic acid, tamarind, it should be Ta, tamarind, imli. Okay, it is the tartaric acid. Apple, malic acid, orange, citric acid, rancid of butter, butyric acid. Now tamarind, when you take the golgappa, understands, we use that one, that tamarind is used. Okay, so it is very tasteful. All of you enjoy when you go outside in the mall, etc. You enjoy with the golgappa. Understands? Now you see, classification of acids. There are 5 classifications based on the number 1 is depending on the basicity. Basicity means number of H plus ion present per molecules. Okay, so it is a monobasic acids, it is a dibasic acids, it is a tribasic acids. What is the basicity? Basicity definition is number of replaceable mind it, replaceable H plus ion per molecules. Okay, if the replaceable H plus acid contains only one, that is the monobasic acid, it contains 4 hydrogen, but replaceable is 1, that's why it is a monobasic acid. Acetic acid, it contains 4 acid, but replaceable is only 1, that's why it is a monobasic acid. H3PO2, it contains 3 hydrogen, but replaceable only 1, that's why it is monobasic acid. Okay, H3PO4 we will learn later on, H3PO4 and H3PO3. We will compare. I will discuss the structure also. Why it is monobasic, why H3PO3 is dibasic, why H3PO4 is tribasic. Very important question is to come. Now I repeat once again, basicity means number of replaceable H plus ion per moles, okay, per molecules. We can write shortly, number of replaceable H plus ion per molecules. Okay, now if the number of replaceable per molecule is 1, that is monobasic acid. If it is number of replaceable H plus ion per molecule is 2, then it is dibasic acid. If the number of replaceable H plus ion per molecule is 3, then it is tribasic acid. Okay, now why H3PO2 is monobasic, H3PO2, PO3 is dibasic, and H3PO4 is tribasic. Now if I know the structure, then you can explain nicely. H3PO2 hypophosphorus acid, this structure actually will get this one, OH, H, H. This name is hypophosphorus acid. H3PO2. It contains only one OH, and this oxygen is more electronegative, that's why it will give the H plus ion. This hydrogen link with the phosphorus, so it will not give the H plus ion. Oxygen is more electronegative than phosphorus, and that's why OH bond is more polar, and that's why H plus it will give only one. Only OH will give the H plus. Similarly, H3PO3 structure is PO, 2 OH bond is there. That means this hydrogen, PN hydrogen, this will not give the proton. This OH, this 2 OH, it will give the proton. OH bond is more polar than the pH bond, and that's why it will give the 2H plus. It will give the 2H plus, and that's why it is dibasic. Similarly, this is hypophosphorus acid, and this is the phosphorus acid. You can say this name is phosphorus acid, or we say the orthophosphorus acid. Orthophosphorus acid. Another is number 3, H3PO4. H3PO4 structure is P. It contains 3 OH bond. Clear? And that's why it can give the 3H plus, OH bond is polar, and it will give what? 3H plus and PO3 minus. PO3 3 minus. PO4, sorry. PO4 3 minus. Phosphate ion. 3H plus and phosphate ion. Now, I repeat once again, H3PO2 contain only one OH, that's why it is monobasic acid. It contains 2 OH and it will give the 2H plus, it will give the 1H plus, it will give the 3H plus, that's why it is tribasic acid. I think it is clear. Question is to come, whether H3PO2 is monobasic, dibasic or tribasic. H3PO2 is, although it contains 3 hydrogen, it is a monobasic acid. Now, next is depending on the strength. What is strength? Now, strength means the extent of dissociation, which is denoted by alpha or X. That is the one important terms, degree of dissociations. Degree of dissociation. Degree of dissociation means extent of dissociation. Extent of dissociation, or we can say the percentage of dissociation. If the percentage of dissociation of acid is more, then it is strong acid. If the percentage of dissociation is less, then it is weak acid. Now see, H2SO4, this H2SO4, it is a what? Strong acid. Why? Because it will ionize completely. H2SO4, it will give 2H plus and SO4 2 minus. Okay, it will ionize completely. But acetic acid, you see, it contains 4 hydrogen, it will gives only 1 hydrogen. Okay. Not only that, percentage of dissociation is less. Suppose 100 molecules of acetic acid is there, it will dissociate less than 30 molecules. Okay? Understands? Normally, if the degree of dissociation, it is denoted by alpha or X. If the alpha is normally less than 30%, then it is weak. Then it is weak. We consider normally, we learn higher class, and if alpha is greater than 30%, then it is strong. We consider normally. Now, extent of dissociation, if it is more, then it's strong acid. If the extent of dissociation is less, it is weak acid. Now, sometimes we see the concentrated sulfuric acid has less strength than the dilute sulfuric acid. Why? Because dilute sulfuric acid will ionize completely, but concentrate H2SO4, sometimes if it is H2SO4 is concentrate, if it is H2SO4 is concentrate, H2SO4, so if it is concentrate, it will ionize H plus and H2SO4 minus. If more water is giving, then it will ionize H2SO4 again, it will ionizes to give the H plus and SO4 minus. That's why we sometimes used to say the concentrate H2SO4 has less strength than the dilute H2SO4, because dilute H2SO4 will completely ionize while concentrate H2SO4 will partially ionize. Okay, these are also very important questions. Now let us comes question. Okay. Then number 3, depending on the source. Depending on the source of acid can be classified also, that is organic acid and another inorganic acid. If the source of acid is plants and animals, then it is the organic acids, and that is source of acid is the mineral. Like say, how we will get the hydrochloric acid? We get the hydrochloric acid from the rock salt, sodium chloride, rock salt, sodium chloride, table salt. Okay. Now sodium chloride, from sodium chloride and H2SO4, by reacting we get the hydrochloric acid. So origin source of hydrochloric acid is the minerals, NaCl. Similarly, nitric acid also they are the mineral acid. H2SO4 also mineral acid. But when the source of acid, like say fruit, like I already shown, okay, that is the fruit like this one. Source is what? This is the source, organic source, like say plants and animals. Okay, so this is the what? Organic acids. Now it is clear. So organic acid I have already explained. When the source of acid is plants and animals, then it is organic acid, formic acid, citric acid, etc. When the source of organic acid source of acid is minerals, like say rock salt, etc., then it is the what? Inorganic acid. The next classification depending on the concentration. Okay, that means when the acid contains more water and less acid, then it is dilute acid. When it contains less water, more acid, then it is concentrate acid. Concentrate acid means less amount of water. Okay, concentrate HCl, we write this concentrate conc HCl, conc H2SO4, conc nitric acid. Okay, now dilute HCl means it contains more water and less acid. Dilute HCl, dilute HNO3, dilute H2SO4. Okay, like that. Dil we write, we shortly write dil, DIL, dilute. DIL, dil means dilute. Okay. Then next part is depending on the, now one question I am telling you, when you do the dilutions of acids, what do you do? We put acid to the water or water to the acid? What you will do? This is my questions. Can you tell me? So normally you think that anything can be done. When you want to dilute any acid, which acid is highly concentrated, normally HCl is 2N normal. Now if you want to dilute it, what you will do? If you put water to the acid, it will spurt out. Okay, it will spurt out, very dangerous. When you want to dilute, we will take large amount of water, 200 cc, 500 cc water, whatever it is, want to make it dilutions. Then we put the concentrated acid to the water so that heat produced does not spurt out. It will be in the water. Understands? When the heat produced, it will be distributed inside the water. But if you do the opposite things, that means when you put the water to the acid, so heat produced cannot disperse inside the acid. Okay, that's why it will spurt out. I hope it is clear. When you want to do the dilation of acid, we put what? We put the acid to the water. Very, very important, not the vice versa. Then depending on the molecular compositions, that means acid contain hydrogens, some minerals, other element, non-metals, nitrogen, sulfur, etc., and oxygen also. If the acid contain oxygen along with the hydrogen, then it is called oxyacid. And if it does not contain oxygen, hydrogen and other non-metal, then it is hydroacid. HCl, H by H does not contain oxygen, so that's why it is a hydroacid. Oxyacid means which contain, apart from the non-metal and hydrogen, oxygen is there. So this is the oxyacid and hydroacid. Okay. Now some acid base reactions. Okay, last I do some question answer I have kept. Now HCl, H3PO4 I have told you. So when it will ionize, what will happen? First it will give H plus and H2PO4 minus. Again H2PO4 minus, it will ionize to give the H plus and HPO4 double minus. Again HPO4 double minus, it will ionize to give the H plus and PO4 phosphate ion 3. Now if we add these two, what will happen? This will cancel out, this will cancel out. H3PO4, H3PO4, it will gives 3H plus and PO4 3 minus. Now this is how you can write. Okay, when you do the acid base react to produce salt and water, so different types of salt will get. Okay, if the hydrogen present, then it is called acid salts. Okay, if it does not contain hydrogen, then it is the neutral salt. That will learn later on. Okay, so another reaction I am giving, acid like say H2SO4 and base NaOH. What will happen? It may contain NaHSO4 and water. When it replaces only one hydrogen, the sodium bisulfite, acid, base, this is the acid, I told you, base, react to produce salt and water. This is the salt and water. Okay? But this salt is contains hydrogen. We will learn later on that this is called acid salt. Better to say this is the acid salt. Now again NaHSO4, if it reacts with the NaOH, it will give the NaHSO4 react with the NaOH, it will give what? Na2SO4, and that is the normal salt, water. This contains no hydrogen, it is a neutral salt or normal salt. So we have learned two types of salt also over here in these reactions. Then you see some dibasic acid, commonly use some dibasic acid like say H2SO4. I told you H2SO4 already I have informed you, it gives the 2H plus and sulfate. Can you name the other dibasic acid? I told you it is a oxalic acid. Oxalic acid, what is the formula of oxalic acid? Oxalic acid actually formula is this. But when it contains two oxalic acid crystal, when it is a solid still, this is a here solid, there is some solid acid are there. Acid contains solid and liquid. Okay, there is boric acid H3BO3, that is a solid acid. H3BO3, that is a boric acid used for the IOS purpose. Boric acid. Okay, this is also solid acid. Oxalic acid, ink eraser, this is also solid acid. So this in solution, what will happen? We can write shortly a COH, and it will ionize to give CO minus oxalate ion and 2H plus. It is a dibasic acid. Tribasic acid, I have shown you the H3PO4 details I have shown you. Okay, this is the tribasic acid. Similarly, the monobasic acid are there. One monobasic acid are there, acetic acid, CH3COOH, more correctly structure is CH3COOH. We learn later on organic chemistry. Okay. Now this OH bond is polar and it will give the H plus. It will give the H plus. This hydrogen, carbon hydrogen bond not polar, it will not give the H plus, and CH3CO and O minus. Shortly it will write CH3CO minus. It is the acetate ion. Acetate ion. It will form and this give the proton, and any compound give the proton, that is the acid. It is a monobasic acid, although it contains 4 hydrogen, it gives only one replaceable hydrogen, that's why it is a monobasic acid. It contains 2 hydrogen, replaceable 2 hydrogen, dibasic acid. And the last questions, there is a question, let us discuss some questions, important questions. Now you see, which of the following is an organic acid? Which of the following is an organic acid? Obviously we can answer it. Okay, nitric acid, sulfuric acid, hydrochloric acid. Inorganic acid, organic acid is citric acid. Okay, lemon contains citric acid. Now next question, which of the following is a tribasic acid? Tribasic acid means which contain replaceable 3 hydrogen. Tribasic acid is H3PO4. Okay, that you know. The next is question number 3. If CO2 gas is passed through the solution A, it turns milky, then the nature of the solution is what? Milky means what? Carbon dioxide gas is there, it will form milky if the carbon dioxide, if it is passed from the lime water, and it gives the what? Calcium carbonate, okay, and water. That means it will give the milky white PPT if it is basic. Answer is basic. Now solution is basic. Calcium hydroxide is the lime water, that is the base. Last question, next question is, an acid reacts with the crushed egg, the shell of the egg, to give a gas. That gas turns lime water milky. Same thing, lime water milky, this is the lime water milky, means it from the, due to the formation of calcium carbonate. This is the milky white PPT. We used to say milky white PPT. PPT means precipitate. Okay, shortly we write PPT. Milky white PPT. The eggshell contains what? Eggshell contains calcium carbonate, or limestone used to say, calcium carbonate. Last question is, which of the following is our hydroacid? Is our hydroacid? Is oxyacid? We know HNO3 contains oxygen, oxyacid, HCl hydroacid, HBr hydroacid. So answer is both B and C. Thank you all. And today, if you have any doubts, you can just mail me the questions. Okay, so already written over here, badruddina@tigps.in. Thank you for the next class we'll discuss the bases. Okay, I'm ending the session over here. Thank you all.